All right, guys, on this VSEPR worksheet, I had some questions about it, so I wanted to go through kind of the steps that we talked about in the notes and then how to properly go through it. So in each question, you're going to, in the box, draw the full VSEPR shape, and then the name of the molecular geometry, or you can get this from your foldable or the notes, and then circle whether it's polar or non-polar. And so I'm going to go through one of these with you. We're going to do, let's do silicon dioxide, SiO2. And so over here I have my steps. First is to find the sum of valence electrons. So we have silicon and oxygen. And so back to my periodic table, silicon here. There we go. Silicon is in group 14, 4. And then oxygen, group 16, 6. And so silicon will have 4 valence electrons, and then oxygen will have 6, and there's 2 of them. And so 12 plus 4 equals 16. So 16 is my magic number that I need to make sure I get to as I draw these dots. So back to my notes. There we go. So determine the central atom by the least electronegative. Remember, carbon is always the central, but we have silicon and oxygen. So we're looking for whichever is more left and more down. And so on your periodic table, it tells you the least electronegative is going to be opposite that arrow. And so silicon is our leftist and downest one. So silicon will be our central atom, and then you'll draw everything else around it. Connect the outer atoms to it by a single bond. I only have 2 oxygens, and so we'll put them on either side with a single bond. And so anytime you draw a bond or dots, you've got to account for it. And so a bond is 2 electrons, and I drew 2 of them. So 4 is my running total so far. Remember, 16 is our max. Next step, step 4, is to fill the octets of the outer atoms, unless it's hydrogen. We don't have to worry about that, so we're going to fill the octet. The bond is 2. We need to get to octet, which is 8. So we're going to give each oxygen 6 electrons. And so we did 6 times 2. 12 plus 4 is 16. So we've reached our max on electrons, but we're not done yet. So there's some steps to go through. Step 5 is to fill the octet of the central, but again, we're out of electrons. So step 6 says if you run out, you will take a pair from the outer one and make a double bond or a triple bond, as the case may be. So you just keep doing that until you get to the octet. Silicon currently has 4 electrons. It's got 1 bond here and 1 bond here, so each bond is 2, and it needs 8. So what we're going to do is take one of these pairs, it doesn't matter which one, I just take the top first, and we're going to take it away, and then it will become a double bond here. And then we're going to do the same thing on the other oxygen, because we need to get to 8 over here. And so we're going to take away those 2 dots and create a double bond. So this will have 2 double bonds. And so I didn't change my number of electrons, it stayed the same. And so my 16 and my 16 is there. I filled my octet of the central, so I'm done with that part. For molecular geometry, this has 2 pairs, or 2 bonds, 180 degrees apart. And so according to this chart that we showed, can't get it moved over. There we go. This looks most like the linear one. There are 2 bonds, no lone pairs. So if you have your foldable or you have this chart, either way, you've got a central atom and then 2 bonds to it. So the molecular geometry here will be linear. And then for polarity, you're looking for any one side different from another. And so on this one, both sides, oxygens on this one, they are double bonded. They're both oxygen and they both have 2 lone pairs. So because they're both the same, it would be non-polar. I don't know why I'm not drawing. There we go. Non-polar. If any one side is different, it's going to be polar. So you're going to do that for each one, just following those same steps. Remember, there's a few exceptions. So there were some exceptions up here that we talked about. On this slide. So carbon always has to be the central if it's there. Hydrogen will never be the central, and boron is stable with 6. And so in number 3 here, you have boron. So there's one of your exceptions. We talked about sulfur. Sulfur is kind of unique as well, but I want you to draw it as we talked about. Sulfur actually makes kind of a different type bond, but I want you to use what we talked about in class to draw those. And then same with nitrogen. Just follow the rules and you'll be fine. If you go look up stuff, you're going to get different things and it's not going to be right. So follow the rules we went over in class and everything will be fine and dandy. If you go and look up stuff, it's going to be different. And because it's not the way we did it in class, it will be wrong. So make sure you follow the rules we went over in class.